Top 10 Fastest Supercomputers in the World, 2025 edition. Exascale Power Unleashed. Intro. Picture a machine that can do more calculations in 1 second than your laptop can in a lifetime. Machines that simulate the Earth's climate, discover new medicines, design materials atom by atom, and train the largest AI models in existence. These are supercomputers, the giants of computational power. As of mid-2025, several supercomputers have crossed new thresholds of speed. In this video, we travel into the heart of high-performance computing to uncover the top 10 fastest supercomputers in the world, 2025 edition. The names, the numbers, the innovations, and why they matter for science, AI, and all of us. What makes a supercomputer fast? To rank these machines, researchers rely on the top 500 list, updated twice a year. Key metrics include Armax, how fast a system can solve linear equations in benchmark tests, LINPACK, measured in flops, floating point operations per second. RPEAK, the theoretical maximum. Cores, CPU cores, GPU/accelerator cores. Interconnects and memory bandwidth, how fast parts talk to each other. Energy efficiency, cooling, physical scale. Crossing 1 exaflop, 1 quintillion flops, is a major milestone. But speed alone isn't enough. Balance, efficiency, and real-world use matter too. Supercomputers also rely on parallelism, thousands or millions of CPU/GPU cores, high-speed interconnects, massive memory, and optimized cooling systems. They cost hundreds of millions of dollars, consume massive power, and are often key national assets. Top 10 fastest supercomputers in 2025. Below are the current fastest systems ranked globally, as per top 500/high-performance computing reports in mid-2025, with their real speeds and important characteristics. 1. El Capitan, almost equals 1.742 exaflops. Located at Lawrence Livermore National Laboratory, USA. Built by HPE, Cray EX255A, using AMD's 4th-gen EPYC CPUs and AMD Instinct MI300A accelerators. Achieved 1.742 petaflops Armax, 1.742 exaflops. Uses Slingshot 11 interconnect. Operates under TOS, its OS, at a national lab with missions including national security, scientific simulations, AI, and materials research. Why it matters? It holds the top spot on the top 500 list as of mid-2025. It leads not only in raw speed, but in application capability, running real scientific climate, energy, and physics workloads. Also noteworthy for its energy usage, cooling, and scale of cores. 2. Frontier, almost equals 1.102 exaflops. Based at Oak Ridge National Laboratory, ORNL, Tennessee, USA. Built by HPE, Cray EX, with AMD optimized 3rd-gen EPYC CPUs, AMD Instinct MI250X accelerators. Armax 1.102 exaflops. What makes Frontier special? It was the first supercomputer confirmed to exceed 1 exaflop sustained performance in real applications. Widely used in climate modeling, computational biology, physics, AI. Also, it's a reference point in energy efficiency. Its power draw, heat dissipation, and cooling systems are state-of-the-art. 3. Aurora, almost equals 1.012 exaflops. Located at Argonne Leadership Computing Facility, USA. Designed by Intel and Cray. Capable of 1.012 exaflops Armax, with even higher peak potential. Uses a mix of Intel's Xeon Max CPUs and data center GPU Max accelerators, linked by high-speed interconnects. Why it's a top contender? Aurora is built for scientific computing, AI, physics, including nuclear research, simulations, and large-scale data. Its architecture pushes GPU/CPU synergy, which is crucial as more workloads demand mixed precision computing. 4. LUMI is almost equal to 0.380-0.40 exaflops. Located in Finland, a pan-European project under EuroHPC. Delivers 380 petaflops Armax. Uses AMD hardware, good interconnects, focused on climate science, AI, life sciences. Why it stands out? It's among Europe's best performing systems, emphasizing energy efficiency and balanced design. It's not the fastest Exascale, but it's fast enough while being more accessible for certain academic and scientific communities. 5. Jupiter Booster, Germany/Euro HPC, 0.793 exaflops. The Jupiter system from Germany, Euro HPC, is Europe's fastest supercomputer in 2025. The booster module has approximately 793.4 petaflops Rmax. Built for sustainability, energy efficiency, driving European science and climate, life sciences, AI. 6. Eagle, USA Cloud, 561.2 petaflops. The Eagle supercomputer is a high-performance system in the Microsoft Azure cloud, noted for its significant processing power. The system is accessible to developers and commercial interests, unlike many top-tier supercomputers reserved for scientific research. Performance. In late 2023, it achieved a 561.2 petaflops, making it the highest-ranking cloud-based supercomputer at the time. A petaflop is a measure of a computer's speed, representing 1 quadrillion floating-point operations per second. Hardware. Eagle is powered by Intel Xeon Platinum 8480C processors and features NVIDIA H100 GPUs, linked by NVIDIA's InfiniBand NDR technology. This hardware is optimized for artificial intelligence, AI, and high-performance computing, HPC, tasks. Manufacturer. The supercomputer was built by Microsoft. Used for cloud high-performance computing, model training, large-scale AI workloads. 7. HPC-6, Italy, for 77.9 petaflops. HPC-6 is a supercomputer installed in the ENI Green Data Center in Italy, achieving 477.9 petaflops of performance. Built by HPE using AMD EPYC CPUs and Instinct 250X accelerators with an HPE Cray EX system, it was first brought online in November 2024 and ranks as one of the world's most powerful supercomputers for industrial use. Location: Ferrara Urbagnone, Italy, at the ENI Green Data Center. Manufacturer: Hewlett-Packard Enterprise, HPE. Components: AMD 3rd generation EPYC CPUs for high-performance computing. AMD Instinct 250X accelerators. HPE Cray EX and Cray ClusterStor E1000 systems. HPE Slingshot Network for high-speed interconnects. First online, November 2024. Rankings. It is ranked as one of the top supercomputers globally, even reaching 5th place on the top 500 list. 8. Fugaku, Japan, for 42 petaflops. Long a leader, still among top ranked in 2025. Fugaku is a Japanese supercomputer jointly developed by Riken and Fujitsu that achieved a peak performance of 442 petaflops using the HPL high-performance LinPack benchmark, making it the fastest in the world when it debuted in 2020 and held that top spot for 4 consecutive times. While it was later surpassed by newer systems, it remains a leading supercomputer, notable for its use in pandemic modeling, AI, and big data processing, and is still among the world's fastest machines for industrial applications. Performance: 442 petaflops, quadrillions of floating-point operations per second, on the HPL benchmark, though it achieved 2.0 exaflops on a different HPL AI benchmark. Name: named after Mount Fuji, Japan's highest mountain. Key applications: used to tackle large-scale scientific challenges, including pandemic modeling for COVID-19, decarbonization efforts, pharmaceutical development, and analyzing big data. Significance: demonstrated Japan's advanced capabilities in high-performance computing and was designed with an application-first approach to solve crucial societal issues. AI and big data. Fugaku also topped the rankings for AI performance and big data processing capacity, showcasing its versatility. Successor. Japan is currently planning for a successor, tentatively named Fugaku Next, aiming to develop a new even more powerful supercomputer to maintain its leadership in the field. 9. Leonardo, Italy, 250 petaflops. Leonardo is a powerful pre-exascale supercomputer located in Bologna, Italy, with a peak performance of approximately 250 petaflops, capable of over 250 million billion calculations per second. Inaugurated in late 2022, it is a key asset of the Euro-HPC joint undertaking and serves as a vital European resource for research in fields like medicine, climate modeling, and energy. Located in Bologna, operated by Seneca. Performance, 250 petaflops, 250 million billion operations per second. Purpose, to enable groundbreaking research in areas such as cancer, drug discovery, clean energy, climate modeling, and natural disaster prediction. Sustainability, features advanced environmental sustainability measures, including dynamic power consumption adjustment and a water cooling system. European initiative, co-financed by the Euro-HPC joint undertaking and the Italian Ministry of Universities and Research, making it a cornerstone of Europe's high-performance computing strategy. Uses NVIDIA Ampere GPUs, large storage, used heavily by academic consortia. 10. Sunway OceanLight, almost equals 0.314 exaflops. Based in China, Armax around 314 petaflops, 0.314 exaflops. Used for aerospace, weather simulation, big data, large-scale modeling. What makes it unique? Its scale in Asia, its contributions to national and international science, and how it shows that global supercomputing power is distributed, not just centered in USA/Europe. It reflects global trends in HPC, focus on AI, modeling climate, health, and multidisciplinary science. Bonus, emerging trends. El Capitan's rise, how its performance and architecture pushed it past frontier. Energy efficiency. Many of these machines consume tens of megawatts. Cooling and energy waste are huge concerns. Engineers are optimizing for performance per watt. AI plus HPC convergence. More supercomputers are used not just for simulation or science, but also training large AI models, simulations, and hybrid tasks. In closing, these 5 giants, El Capitan, Frontier, Aurora, LUMI, and Sunway OceanLight, push the boundaries of what's possible. Each represents years of engineering, massive investment, and human ingenuity. From climate models that predict storms to AI systems that might design new medicines. From crunching the data of galaxies to helping understand pandemics. These supercomputers are quietly working behind the scenes of progress. Which of these machines fascinated you the most? Comment below. If you enjoyed this, don't forget to like, share, and subscribe to iNest Facts for more deep dives into world-class technology.